The second, these dashed lines, notice there's dashed and solid lines. The dashed lines are going to represent, kind of thinking of it like almost like the clock, but we're not going in like starting at the top. We're going to rotate 30 degrees. Okay, so we're going to just fill in the dashed lines, well, some of the dashed lines. This one is 30 degrees. Go up to the next dashed line, not the solid line. This one is 60 degrees. What do you think then the solid one is? 45 degrees. Okay. So I have the dashes are all going to be multiples of 30. You're going to notice the solids are all going to be multiples of 45. Okay, so we got 30, 60. Over here, I'll talk about in a minute. If I was 30 degrees away from 180, I would be at 150, and another 30, I'd be at 120. We'll fill those in a second. What do you think this top one is? 90. Okay, we're on a dashed, so let's fill that one in. 90 plus 30, what does that give us? 120. That one's 120 degrees. Okay, and then let's go down to the next dashed one because that's an easy one. What's 120 plus 30? 150. And then halfway in between here is a 45-degree angle, so there's two ways we can find it. You can take 90 and add 45 to it, or you can take this, which is 180, and subtract 45 from it. Okay, what do we get when we take 90 plus 45 or 180 minus 45? 135. What is that? 135. So this angle is 135 degrees. This one is 180. Okay, let's keep going. Now that you kind of get the increments, we're going to add 30 to 180 because I'm rotating around this circle. 180 plus 30, what does that give us? 210. For the next solid line, we're going to go back to the 180, and it's a 45-degree angle. We're going to take 180 plus 45. Is it 225? Okay, this next one, you have two choices. You can add 30 to the 210, or you can take 30 away from 270. So, what's up? 240. And then all the way down to the bottom is 270. Okay, let's keep going. What's 30 degrees past 270? 300. Let's go back to the 270. 270 plus 45. 315. Let's go back. If we went to this next one, that's 30 degrees past 300. That would be 330. And then finally would be 30 degrees past 330, which brings us to the 360. Okay, we went all the way around. So the other thing that you need to know is that in these triangles, we already talked about how the radius is 1. And what I'm going to do is we're going to just do quadrant 1 right now. If I was talking about, be careful where you're going to get these from. This triangle right here, if it formed a triangle, would be a 30, 60-90 triangle. We're talking about the 30 degrees right there. And so the coordinates of this right here would be root 3 over 2 for the x coordinate, and then 1/2 for the y coordinate. And we're getting that from a 30, 60, 90 triangle that I showed you on the board earlier on. Okay, the coordinates of this point are based on a 45, 45, 90 triangle. They are root 2 over 2 and root 2 over 2. And the coordinates of this point, it's like the 30, 60, 90 triangle has flipped around. So it has a 1/2 and a root 3 over 2. And at the top, if this has radius of 1, would we all agree that this has coordinates 0, 1? All right, what are the coordinates of this point then? 1, 1, 0. Okay. All right, so when I teach students the unit circle, I know that the angles are all different, right? But once the angles are on there, then these points, nothing's going to change about them except their sign, okay? So what I mean by that is, this is quadrant 1, right? Both the x and the y coordinate are positive. What's going to happen if I reflected these points over here? One of the coordinates is going to change signs. Which one? The x is going to be negative now. Okay, so what we're going to do is we're not going to write anything really new here. We're going to reflect these points across the y-axis. So if I took this top point and reflected it across over to this top point, the coordinates would be negative 1/2 and root 3 over 2. So the x is going to be negative, the y stays the same. Let's reflect the 45-degree point over. And so the coordinates of this point are negative root 2 over 2 and root 2 over 2. Let's reflect this one across. So we have negative root 3 over 2, still 1/2. Okay. Going down here, the coordinates at 180 are negative 1 and 0. Okay. Now, for this quadrant, now that I have this, I am going to take these 3 points, and now I'm going to reflect them over the x coordinate. So this point, the 60, the 150 matches with the 210. What's going to happen now? Over in this quadrant, because this is an x and y axis, won't both coordinates be negative now? Okay, so let's flip this one down. We still have negative root 3 over 2, but this now is also negative 1/2. I reflect the 45-degree angle down. I get negative root 2 over 2, root 2 over 2. And then I reflect the 60-degree one down. It is negative 1/2 and negative root 3 over 2. Okay, down at the bottom, coordinates of this point are 0, negative 1. Let's go back to the original. I'll call this is quadrant 1 over here, right? Let's go back to quadrant 1. To get my last quadrant, I am going to take these 3 points, and now I'm going to reflect these ones over the x-axis. So this time the x will stay positive, but the y will become negative. So the point that's reflected down over here is root 3 over 2 and negative 1/2. We have root 2 over 2 and negative root 2 over 2. And then we have 1/2 and root 3 over 2. Oops. Make sure that negative's there. Negative root 3 over 2. Okay. So you might be thinking, yeah, what, Ms. Montgomery, that's fine and good and all that, but why? What do these points tell us? Okay, in a triangle, we've talked about SOHCAHTOA, right? So if I'm looking at this as a triangle right here, I'm just going to take this as my example. Let's pretend this is a triangle. This x coordinate, that root 3 over 2, is the adjacent piece. This y coordinate, the 1/2, okay, adjacent. Which function has to do with adjacent over hypotenuse? Cosine. This is the opposite piece that has to do with sine, and we'd be dividing them by the hypotenuses of 1. Well, what happens when you divide something by 1? What happens when you divide something by 1? Nothing. It doesn't do anything. So on all these, this is the aha moment. I know you're not going to be as excited as I am. Each of these points, the x coordinate represents the cosine of the angle, and the y coordinate represents the sine of the angle. So each of these points represents the cosine and the sine without having to draw a special right triangle every single time. So it becomes really useful when you have to memorize special right triangles, because essentially if you memorize the unit circle, which I haven't decided if I'm going to make you do, next year you will take a whole unit circle quiz next year if you're doing pre-calc, you will. But every single point around here is a cosine and a sine. All right, so let's just go through the positive and the negative. In quadrant 1, the signs are both positive, right? So the positive functions are the cosine. I'm going to just do this. I'm going to just do plus plus. Cosine's positive, sine's positive. Let's go over to this side. On this side, it's negative positive. That means the cosine is negative, but the sine is still positive. Over here, we have both are negative. Cosine is negative, sine is negative. And then over here, the cosine becomes positive again, but the sine becomes negative. Okay. So, let me just give you an example of the kinds of things we're going to work over the next few days on with this. Suppose I asked you, hey, what is the cosine of 60 degrees? Exactly. Because sometimes I'll ask you that exactly. Let's flip over to our unit circle. We're going to find 60 degrees. The cosine is the x coordinate. The answer to that would simply be 1/2. So that's the kind of thing we're going to ask you with that. We'll do some whiteboard right now to finish up. Let me give you another example. Let's do a different quadrant. What if I said, hey, what's the sine of 135 degrees? Okay, so I go to 135 degrees right here. The sine is the y coordinate. I just get to write down the root 2 over 2 without having to draw a special right triangle. So that's kind of the gist of the unit circle. All right, flip over to this side though. Grab your whiteboard, let's do some. We're just